let's create a smart contract in Remix and we will follow the same pattern. Ask the question and then solve. As we are creating a counter smart contract, we need to initialize a variable. In other words, create a space to store the data. You in 256, I choose you. And we declare it as public so that a getter function is automatically created. Now let's set the data. The default value of u in 256 is 0, but we will do something to set the data. We will create a constructor with a parameter convention underscore with parameter name. Now let's create a function that will increment the value of the variable. Quick maths, counter plus equal to 1. We created the increment function. All that's left is a decrement function. Well, as we declared an unsigned integer, we won't be able to go below 0. But it is better to have an error message rather than putting the user confused. We create a require function and then decrement the value. We can also create a custom error message that will save some gas because Ethereum doesn't like things with double quotes. Now, as soon as we compile the smart contract, a bunch of things are generated, out of which the most important is the API. It's also known as Application Binary Interface. We then deploy the smart contract. Note, the parameter values are to be given before deployment or on the time of deployment. And then the address is generated. Time to interact. As you can see, there are 4 functions: decrement, decrement again, increment, and counter. Incrementing does work completely fine, but look at the difference in error when we go below 0. Now, if you are a beginner and you have MetaMask, let me tell you, you can deploy on any Ethereum based chain with Remix's injected Web3 option. We will be using Avalanche's Fuji C chain. As you can see, I have 10 AVAX and on deploying it, I lose some gas and the buttons magically interact with Avalanche Fuji C chain. Check it on Block Explorer by either the transaction hash or by the contract address. Now let's copy its ABI, copy the contract address, and we completely break bonds with Remix as of now. And now it's time to create our decentralized application. So what exactly happened here? I had previously set up a RPC node in MetaMask so that my MetaMask can form a connection with Avalanche's Fuji C chain, and which in turn can connect to Remix so that I can deploy my Remix's code to Avalanche Fuji C chain. Now the bytecode is deployed to C chain, and all that is left with us is smart contract address, the node, and the API, of course. Now what we are going to do is check if we have MetaMask installed or not. I cross-checked it from Google because this is a code that you should copy. You should not remember this. Our main goal is to get the contract instance. That's it. Now I have a Web3 provider instance by the command web3 is equal to new web3 provider. Previously I put a wrong command and wasted 20 minutes, but it doesn't matter. I will be storing the address in a variable named attr. Create a function named load account that checks the connectivity by web3.eth.getAccounts. Now the only thing that's left is to create the contracts instance. web3.eth.contract, then we have to put the ABI and contract down below. I have already imported both of them into the console, so it should not matter much. Now we are all good. Now all the hard part is over. Now just call the function inside the async function. The functions mean the solidity codes function, and now we are able to easily interact with the smart contract. Done. Let's talk about Hardhat or Truffle. First, we try to know what do they actually do. So they are tools used for deploying a smart contract to Ethereum based chain. They can write tests using Chai or Mocha framework or whatever the instructions they are, and Hardhat has its own local blockchain, and Truffle does not, so you use Ganache. Now, let me recall what I just said. I said testing, deploying, and compiling. Didn't we test in a Remix? Didn't we compile in a Remix? Now, how did we test? We tested it manually. We direct interacted, and there is a blockchain which is the London virtual machine, right? That is, that starts from Genesis block in my opinion. Yes, yeah, that starts, and that's a fake blockchain. So we almost did everything that these frameworks do. So why are we even using these type of frameworks? Not frameworks, tools. It's my bad. Tools. Why are we using these type of tools? Now let us assume that there is such a large contract which has, and every single function has like 12 to 13 parameters. Now in that cases, what are we supposed to do? Now, as every single function has tons and tons of parameters, and we have also created a custom data type, and that data type is being pushed to an array. So do you think that it is feasible to compile, deploy, and then test it again and again and again? Wouldn't it be a tedious process? So in order to overcome that type of situation, we use Truffle. Now Truffle or Hardhat, whatever tools we have, right? Now, when are we supposed to use that? Means, as a beginner, I am to an intermediate. I won't consider as myself as an intermediate. I am too a beginner to intermediate developer. So, what do you think? When should we do? In my opinion, I think you should stick to Remix as long as it is. As long as you feel that okay, no man, it's just getting out of hand. As simple as that, man. So if you still haven't noticed, I haven't told you how to interact with the functions of the smart contract. I hope that you have Google searched it. If not, then I'm pointing the arrow, and that will probably give you a hint. And while doing this, there are a lot of red errors. I thought that what are these errors, but then I understand that I have no idea why these occur. But the functions seem to be working fine, the transactions are complete, and the values are incrementing and decrementing. So yeah. And now let us create another smart contract in order to distinguish between Ethers.js and Web3.js. Because I already said in the previous part that we only have to find a way to call the function present in the smart contract, and for that we need to create an instance of the smart contract, of course. Now let's have a first look at the smart contract. We have a user defined data type, and we create a mapping to keep track of it. It consists of an integer, a string, and a boolean value. This contract was especially chosen for you in order to show the difference between the return type. Before starting, make sure that you have installed Web3.js or Ethers.js. Now what the hell is Infura? It's a node provider. We connect to the blockchain via this API only, and in this case we are using Common testnet. As you can see, the return value of a user defined data type is kinda different in Solidity, because there are total 6 values, out of which the user defined data type only had a 3. So as you can probably figure it out, the 0 corresponds to A, 1 corresponds to B, and 2 corresponds to C. They are just duplicate, and they're present twice. So as you can see, Ethers.js and Web3.js both are really easy. You just have to find one and deep dive into it. Now on the surface level, you have to just create a contract instance and interact with it. And let's check out the return type of Ethers.js. It's actually an array, and array consists of like big numbers and stuff. So you have to just convert it to string, and you will get 3 different values in a very bad manner. With everything we have discussed so far, I don't think that there should be any issues regarding creating the dApp. So in React.js, the code is a little bit different. but the functions used are the same. So you should at least have the knowledge of use context, use effect, and use state. So we will create our own context store such that we can connect MetaMask, store our current address, and create contract instance, so that I can get the power to use these in every component without props drilling. Now we use the connect MetaMask function, window.ethereum.request, and set the current account to the variable named account. Now the contract context we give the provider in the web3 variable, and set contract instance in the contract variable, and we then import those two functions and one variable. Connect MetaMask button triggers the connect MetaMask function, and we create custom buttons for interacting with the functions of the smart contract by calling getter functions by .call, by calling setter function by .send, and we also have to specify from which account. Display it accordingly and beautify your application. And this we conclude this video, and I hope that you create your own template before moving forward. Make sure you check out Web3 Learns' website and join our 1-week bootcamp.